Can you just replay it over and over again? What happens when you plug in? Hold on. How do you take a limit? You take a limit of the top, right? And a limit of the bottom. That's how the properties work. So a limit of the top is going to equal, and a limit of the bottom. Now, usually we don't have to do this, but remember, can I say equals 0 over 0? No, because 0 over 0 is a like plug it in your calculator right now. In your calculator and show it to the whole group. 0 divided by 0 equals. Undefined. Error. Plug it in though. Plug it in. Double check. Maybe I'm wrong. Okay. So can I say 1 second, the limit equals this DNE error wrong answer, and then the next second say, oh, all of a sudden it's a number. No. I can't equal two things at once. It's two different things at once. So therefore, what am I doing? I'm, well, hopefully seeing 0 over 0, right? I'm seeing 0 over 0, which I'm going to write after that. What am I going to write after that? Keep going. Good. But, oh, okay, we're doing the lazy way. Okay, so kg. Keep going. Because why? Just because the limit of the top is 0 and the limit of the bottom is 0 doesn't mean the answer is 0 over 0. So what do I have to do? Keep going, but how? Factor. Factor what? Everything. Well, this one doesn't really factor, does it? But what is this factor to be? Okay, cancel. No, they don't match. Oh. So I keep going? What is x squared minus 1 factor to be? Good. And then what happens? Woo! Yeah, right? Now what? Yesterday we said, what do you do first with the limit? You try to plug it in, right? You try to plug it in, direct substitution. But what if plugging in doesn't work because the function doesn't exist there? Just because there's an error, do you stop? No, you keep going sometimes. If you see 0 over 0, you keep going. How? Well, what we just did. And what do you do once you remove the whole? Once you factor and divide, you go back to step 1. So, what's the limit? 1 squared plus 1 times 1 plus 1, which ends up equaling dun, 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 dun. 0 over 0 does not equal 4, so I cannot say equals 0 over 0 because it doesn't equal that. Or I guess I could say equals 0 over 0 and then put like a little not equal to. But it does 0 over 0 tells me keep going. Final answer is 4. Did anybody check on their calculators? By going, what would you do to approach 1? There you go, 0.9, 0.99, 0.99999. But you'd have to come from the other way also. But if you look at the graph, you should see them going to the same place. But you could do 1.1, 1.01, 1.001. But guys, the point of section 12.2 is to not use our calculator, right? Okay, and it goes faster that way. Remember, didn't we love these ones? Because they were, not those ones. Didn't we love these ones? Yeah. But section 12.2 says, okay, well, sometimes it's not quite that easy, but that doesn't mean you can't do anything. What else could happen? Okay. Step number 2 doesn't work. If you guys want, look at the example below as you're writing another trick. This isn't like a do this first and then this and then this. Well, it kind of is. You're supposed to plug in first or try to plug in first. But if you get an over 0, careful, don't say equals. Or if you do say equals, put a slash through it. Technically, your logic is skewed if you say it doesn't exist, it does exist. It doesn't exist, it does exist. That's confusing. Well, I don't know. Okay. If you guys are curious as to why we need this thing called rationalizing, as to why we need this thing called multiplying by a conjugate, Look at the example and ask yourself. Look at the example and ask yourself, does plugging in work? As you're writing, does plugging in work? Property of limit says, go with the top, go with the bottom. See what's happening. Don't I get a 0 over 0? So step number 2 says factor. Do you see any squareds or cubes to factor? I don't. Divide. How do I divide if I have a... I don't know how to do that. So, you get a 0 over 0. We still say, keep going, but how? Isn't a radical a square root? Or something that's really cool. But isn't a radical a square root? If you see a square root, I can almost bet that you should multiply by the, who's the conjugate? Review. The conjugate of a plus b is a minus b. Same thing, just different sign. Now, maybe we should say, but ours are going to have radicals. So, okay, how about this? The conjugate of the square root plus a is going to be the square root minus a. What does that mean? We're going to take our, and we did this way back when, but it's been a long time. The only way that we can multiply and not change the value is if we multiply the same top and bottom. Kathleen, what's up, kid? Oh, I just took the properties of limits that say in order to take the limit of an f over g, I take the limit of f and the limit of g. So all I did is I looked at the numerator, looked at the denominator. Because otherwise, if we just plugged in, we would get 0 over 0. And remember, I mean, you could put a slash through and say, yeah. In years past, we've just put equals 0 over 0. Keep going, which is short. But the problem is once you get to the AP exam, if you write equals 0 over 0, they're going to be like, you don't know what you're doing. I mean, you do, but you don't, because you just said it doesn't exist, and in a second it does exist, and that's not good logic. But you could put like a 0 over 0 and a slash. I think you could do that. I think that's okay. But now I'm multiplying by, okay, wait a minute, who do I have? I have a minus, so I'm going to do the conjugate of a plus. So x plus 1 plus 1. In algebra, you can think of an equation like a teeter-totter, right? You guys know what a teeter-totter is? A teeter-totter is that really fun thing. Although when I was in Baja recently, there were kids and someone totally like flew off of it, which was kind of sad. But teeter-totter, right? And it goes back and forth. Doing, 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 doing. If you put a really heavy person, and it's just like sitting this way on the ground, if you put somebody on, what's going to happen to the teeter-totter? Right? How do I balance it? I put an equally heavy person, right? And then if it's balanced, it'll, right? Okay, balanced, right? Now, what if I have it balanced, which is what an equation is? We're not in chemistry, so we'll say it's balanced. Let's say it's balanced. Let's say it's perfectly like that. Then I put a person on, right? But then I put another person on. As long as you put the same weight on either side, it's going to stay balanced. In algebra, if you add something to one side, you add it to the other. In algebra, if you subtract something from one side, you subtract it from the other. That's what's going on in algebra, right? But in multiplication, just because I know some of you are going to make this mistake over and over and over again, in multiplication, how do we keep it balanced? I want you to think of somebody with a backpack on. Ooh, we're doing the whole backpack weight thing a lot, right? Okay. And they're fine right here until, let's say the backpack is open. Someone says, oh, you have this for homework too. This for homework. If I just multiply on top, it's like I'm adding to the backpack. But how do I balance it? I also have to add more strength, right? Because if I don't add more strength, it's like, okay, fine. And some of you walk around like this. If you add it on top but not on bottom, you're not balanced. You have to add it on top and bottom, right? Okay, so multiplication. I have to multiply by 1 creatively to make it all balanced. What was the point? That's what you guys should be asking. Why do you do this? Has anybody done it yet? Has anybody multiplied yet? All you're doing is foiling, right? I totally lost my marker. There it is. Has anybody foiled yet? Check it. Can't I see these things as a minus b and a plus b? So what happens when I FOIL? What happens when you do first? A square root squared. Is that going to be nice? Yeah, you've already done it, huh, Jason? Then you have the outside. Then you have the inside. On bottom, I'm just going to leave it like this, and you'll see why in just a second. I think you just said is x. Good, 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 good. Can the rest of you guys see why it's x? That cancels out, right? These ones cancel out. What's x plus 1 minus 1? Yeah, good, just x. Why does this make all the difference? As long as I don't multiply the bottom, whenever I multiply by a conjugate, you might want to say something like only FOIL the, that's going to be confusing. Only FOIL the conjugates, I guess? Well, sometimes it's denominators. That's why I have to be careful. But only FOIL the conjugates. So we only FOILed these ones. That one we just left. What can we do now? Yeah, some of you are like, oh yeah, reduce it, plug it in. Reduce it, plug it in. Limit as x goes to 0 of 1 over, oh wait. I'm taking the limit. I can just say equals 1 over square root of 1 plus 1 plus 1, which will be 1 over, oh sorry, it's a 0. Silly me, we should sue. 0 plus 1, sorry, 0. There we go. Square root of 1 is 1, 1 plus 1 is 2. Boop. Just 1/2. It was complicated, but guess what you can always do whenever you get a 0 over 0 with a square root? This procedure. Because once you multiply, then you're going to be able to reduce, then you're going to be able to plug in, then you're going to be able to solve. No big deal, right? Okay, so when do we rationalize? 0 over 0. Keep going, and there's a square root. What do we do when we have a 0 over 0 with polynomials? We factor or we divide, right? So you guys go. You guys go. If you want to, let's say you don't see it right away. So like Kathleen was saying, oh, so you're showing the work as to why it's 0 over 0. Let's say you just get to plugging in because you're like, I like to plug in. 0 plus 4 minus 2 all over 0. And you're like, yay. Square root of 4 is 2 minus 2. And then you're like, boo. Does the limit equal 0 over 0? No. So something else you can do that the AP totally doesn't mind is you can cross it out. You can't do that. Anything you cross out on an AP long answer, they can't look at. They can't put towards you or against you. They can't count for you or against you. Anything you cross out, they say, I'm not allowed to look at. And they literally, I mean, they can look at it, but they can't do anything with it. So that's kind of nice, because you're like, oh, I was going, then I was like, ah, crud. Okay, cross it out. But don't you know what you're supposed to do? Keep going. So even if you don't show the super snazzy, like limit of the top, limit of the bottom, it's not bad that you did the other. Zero over zero. Keep going. So therefore, how do we keep going? By what? Good. Plus 4 plus 2 on top and bottom. Does that make sense, guys? If you know what you're doing, finish the problem for me. I'll catch up in a second. I'm giving people time, but go ahead. Keep going. Go all the way to the answer. Is this anybody's notebook, by the way? I've just been chilling up here. Oh, never mind. No, this is totally a calculus kid. Come on. Oh, and I know whose it is. Kevin Bowie. So much judgment all at once. You guys are rough.
Next period with him, if you want.
Oh, sweet. I'll bring it to you, Johan. Thanks. You guys foiling? How we doing? Do you get the square root to cancel out and the outer and the inner cancels also? Then you end up with x plus 4 minus 4? Isn't x plus 4 minus 4 just going to be x? And aren't my x's just going to reduce? So 1 over who? What am I plugging in? Now some of you might be like, oh, this is always going to happen, so I just won't do the work, and I'll sneak ahead and say, oh, the whole top goes away, and then the x on the bottom goes away. I've only shown you two that are very similar to each other. They can have some different things, but the key is still multiplying by the conjugate. Why? Because it was 0 over 0, and I had a square root. Is that cool? So how do we deal with problems? How do we keep going, factoring, dividing, multiplying by conjugates? Questions? What? Using technology? That's a lame last resort. Hold on. Let's do some weird examples before we do the whole like cop-out of using technology. Now these ones might not have like set steps. I mean, I could write them, but then we'd have like strategies 4 and 5 and 10 and 12 and 16 and 22. So technically, okay, there is this little like, oh, use technology if worst comes to worst. But no, we're not going to do if worst comes to worst. We can do these. I want you guys to try this one. I'm putting the whole calculator worst comes to worst at the very, very, very end of notes. Let's try some more examples. I'm not giving you set strategies, but you do have this whole idea of plug in. You have this idea of like dividing, and you have this idea. Not a bad idea. You'll see. Group 5. Bloop. What color do you want? What color do you want? What color do you want? We'll let Austin pick. What color do you want, Robbie? do you want? Grab a tissue for your nose, or maybe for the whiteboard. Grab a tissue. Em, grab a tissue. Never mind. Sam, grab a tissue. Grab a tissue. Do you have the answer? Did you guys already get one?
Can I grab a different one?
One's there. Almost. Plug in.
Oh, yes.
Ready, set, all pencils and pens down. Bloop. Powwow, turn in, exactly, turn in. Whoever has the whiteboard with the marker, I want you to write this example down. I want you to talk about how to do it. Whoever has the whiteboard and the marker, you're the only one allowed to be writing. I want you to talk about what to do. Some of you said synthetic division. Some of you said normal division. Yeah. Maybe a black one would be better. There you go. Yeah. Is that one rough? Oh, yeah. Let's just throw that one away. Okay. I'll wait and see. Yeah, there you go. All right. Nobody with the pen. You have to use your words. Talk it out. Grouping. Wow, I see grouping. Anybody else thinking grouping? Doesn't always work, but this time it does. No, keep trying, keep trying. He just didn't rewrite it. Adam, put parentheses and see if that helps. And factor it all the way. Like Jason saw it. He just didn't write it. We can. But factor out first. He just...
Factor out more
Mm-hmm.
than this?
Mm-hmm. Can't you pull out what's in common?
Oh. Like that. Okay.
What? Huh?
Okay, question. Question. If you guys looked, I said polynomial division or factoring / grouping. Now, here's my polynomial division, here's my synthetic division, and here's my grouping. Could they all have gotten me to the same place? What's weird though, was my division the normal way of this coming down? No. I took the bigger guy and I said, hey, do you go in evenly? And I already knew it was going to go in evenly because of the 0 over 0. There was a shared factor, so I knew this guy went in. And how many times does this go in? X squared plus 1. Isn't that what you end up with here? Or I could have done synthetic and said, I know that you go into him. How many times? X squared plus 1. Or grouping worked this time. Now, grouping doesn't always work. Be careful. This time was easy to see for some of you. Grouping worked because there was a shared x squared. It comes out. I have x minus 1. Well, whatever. There's an x minus 1. There's a shared x minus 1 with an x squared plus 1 remaining, and then I was able to reduce. But careful, grouping doesn't always work, so here's what else you could have done if you couldn't see it. But what's the final answer? Well, as soon as I get rid of that, I plug it in, plug it in. Good? Good. So that was a weird example because you needed to do some sort of division, some sort of extra factoring, right? Why? Because we got 0 over 0 and we knew we were supposed to keep going. Ready? Somebody new has the marker. Erase the whiteboard. Nobody writing in your notes. Nobody writing in your notes. Somebody new has the marker. You can write in your notes after we figure out how to do it. I want you guys to start thinking about someone new has the marker in the whiteboard. Oh, Tony and Jaden, are you guys too far away? Is that hard? You can still collaborate? Okay. Somebody new has the marker. No one's writing down except for the person with the marker and the whiteboard. I want you guys to talk about what do you think you should do on this weird example. How do you keep going? Go. How do you keep going? I haven't told you. With polynomials, I said factor. With radicals, I say conjugate. With bigger polynomials, I say divide. Try to think like me. What would I say to this one? Jane, you can pop in here and then zoop, zoop. And Lacey, I don't know if you can see too. Just think about it. Think about it. Think about it. What would I say to do? Oh, what? Oh, okay. No. Talk to them. See if it makes sense. But good job, Jason. See if they agree. See if they agree. have an answer back here. Let me see. Hold it up. I have one answer that somebody thinks. Oh, I have two people. I haven't said if they're right or not.
Multiple this is 1. And so this is minus. So the top becomes x minus x. So we put the minus in the bottom of the So x divides the.
I think I see people trying to get rid of the fraction.
Is that your way, Misty? That. New one. Mr. Che.
Mr. Che. Mr. Can I start playing now?
Do you ever use an air fryer doors?
This plus this
Oh, because it's the negative. Okay.
Yeah, so 1 minus x plus 1 is equal to negative x. And
I went over this. Okay.
yeah.
What? That's so complicated. That's too much, Misty. Too much. You feel like you're winning.
What? Whoa, what?
Oh, yes. Yeah, that's not easy to process.
That's if you want to get a common denominator and then mush it carefully, distributing the negative, and then divide by a fraction is multiplied by a reciprocal. And then, okay, my way would say, hey, there's a little baby stuck denominator, isn't there? What's x plus 1 over x plus 1? 1. What's x plus 1 times 1? Careful of the parentheses, right? Which way makes sense? Which way makes sense? I don't know. Which one makes sense? All right, get it in your notes. Whichever way makes more sense. One way says I need a common denominator, and I need to make this guy over 1 so I can multiply by the reciprocal when I divide. This way says I have a little baby stuck denominator. Let's go ahead and multiply the top and the bottom by him. All right, whichever way makes more sense, get it in your notes if you don't have it yet. Whichever way makes more sense, get it in your notes. Do you guys kind of see what we're doing, though? We get a 0 over 0, and then we're playing with it. How? Factoring, dividing, simplifying. We're trying to change how it looks. With radicals, we need conjugates to help us change how it looks. But we're trying to change it up so we can reduce. Why? When you see 0 over 0. Why are we trying to reduce? When you see 0 over 0, do you notice every single time something is reducing away? Even when we multiply by conjugates, something reduces away. Why? When you see 0 over 0, what do you need to be thinking?
KG.
Keep going because it's a whole. And as Adam is saying up here, you guys hearing him? A whole is what kind of discontinuity?
Removable.
Removable. What are we trying to do? Move it. True? 0 over 0. Keep going. It's a whole. It's removable, which means if I'm trying to think about the limit towards a whole, guys, doesn't the limit exist because the approaches match?
Yes.
right? The approaches match. The limit exists. You find what the limit is. Look at your shoes. Make it match. From either side, the limit is approaching the same place. I don't care if in and out is open or closed. We're approaching the same place. The limit exists, but how do you find it? You fill the hole. And how do you fill the hole? You remove it. How do you fill the hole? You remove it. The hole is there. The error in the original function is there. But if we fill the hole, we solve the limit. How are we doing? How many of you guys chose to write down the left one? How many of you guys chose to write down the right one? And then a few of you didn't choose? Anyway. Anything else weird? Ah! 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 Oh, hey! We know him. Okay, technology we're good on. Can I hold on? Can we just look at this page real fast? No? What do you guys see? Yeah. Except we've already written him down, actually. Let me make him a little bit bigger. We just haven't put names to him. No. No, hold on. We've already done him. You guys just don't realize it. Have we talked about coming from the left? Right? Have we talked about coming from the left or coming from below? Right? Guess what? We're just writing it down in like note form. Are we talking about coming from, have we talked about coming from the right or above? Yeah. So what is this page doing? It's just basically writing notes for what happens if we see a minus. Oh, that's really rough. You can barely see it, huh? If x approaches c minus, that means we're coming from the left or below, right? And if we see the limit as x approaches c plus, we're coming from the right or above, yeah? So we're just writing down that there's an actual name for these. They're called one-sided limits. Why would they be called one-sided limits? Well, because a normal limit, what do you need? Two sides. So we have to say, oh, it's a one-sided limit, because this says only from the left, only from the right. So if you see anything, maybe in homework, maybe in the future, where it says come from 0, negative, hopefully you know that means from the left, right? And what would you need to be thinking for this guy? From the right. And when you see just a normal limit, what do we need to be thinking every time? From both. AKA, do they. What's the word I keep on saying every time I say, look at your shoes?
Do they match?
Do they match? And maybe we'll talk about him a little bit more tomorrow. But long story short, this guy actually ends up Monday. Psh, you guys want to come to school and do math on a Saturday, don't you? Party poopers.
I have APs next week, so yeah, me too. That's 2 weeks. Your AP test is
Hey guys, do you see this graph? What would we answer if we're just coming from the left? Which in and out is this headed to? Which in and out is this guy headed to? So what's the limit overall?
does not exist.
But why am I showing you this? What would happen if you plugged in? 0 over 0 isn't always a number? All right, cool kids. The only thing we didn't get to talk about was how to use your calculator. Wait, we already did that. Robbie, hold on. And then how to take a limit of, you guys did great though on the random one I threw at you, so why don't you just try that one too in homework, huh? Come Monday with any questions. Robbie, come here. Bye, guys.